Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video I will attempt to predict the future price of Bitcoin using a simple machine learning model and PyCaret. Now this is meant to be a fun project using machine learning, so please take it with a grain of salt. So I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to program in Python. So all you have to do to get started is go to this website and then log in with your Google account and get started writing your Python code. So if you're going to code along with me, go ahead and click on File, then click on New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. And before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button to be notified about new videos from this channel. Hit that bell notification. Also, you can get the code or data set or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. And the material in this video is purely educational and should not be taken as professional investment advice. So invest at your own discretion. All right, so the first thing that I'm going to do is install some of the packages that I need for this program. So I'm just going to type here pip install, and then I'm going to put PyCaret. Okay, and then I'm going to run this cell by clicking this button here to the left, and then hopefully it will install everything that we need. All right, so what I'm going to do is I'm going to pause the video while it installs, and then I'm going to unpause it when it's done, so that's faster for you all. Okay, so it looks like the package has been installed. So I'm going to go ahead and create a new cell by clicking that code button in the top left. And now I'm going to install markup safe. So just type pip install markup safe equals 2.0.1 and run that. And this should be relatively fast, I believe. So there we go, it's done. All right, so let's create a new cell and let's install one more package. So just type pip install Jinja 2 and let's run this, and I believe this should also be relatively quick. All right, so excellent. So those are the three packages that you will need to get this program started. All right, so next I'm going to go ahead and click that code button again, and I'm going to import the libraries that I will be using throughout this program. So I'm going to import pandas as PD. I'm going to import numpy as np, and from sklearn.model_selection, I'm going to import train_test_split, and from PyCaret.regression, I'm going to import star everything. All right, so let's go ahead and run this cell. Okay, and it looks like everything is good there. So next I'm going to load the data set. So from google.colab, I'm going to import files, and I'm going to type files.upload to upload the CSV file that we're going to be using, which contains data on Bitcoin's price. All right, so let's take a look at that file after we read it in. So first we need to read in the data, and we need to store it into a variable. All right, so I'm going to create a variable called assets and set it equal to pd.read_csv, and I'm going to read this asset.csv file, and then I want to show the data. All right, so I'm just going to type assets here, and let's run this. All right, so this is our file, and we can see that contains the price of Bitcoin from 2014 to 2022. All right, so let's go ahead and create a new cell. And now in this cell, I'm going to create a variable for predicting one day one day out into the future. All right, so I'm going to call this variable future underscore days, and I'm going to set it equal to 1. And then I'm going to create a new column. This new column will be the target column, or the dependent variable, shifted in units up. In this case, n is equal to 1. All right. Okay. So let's create that. Let's create that column. So just type assets, and then let me make sure I have this right. So assets. So assets, I'm going to call this column future underscore price, and I'm going to set this equal to assets close price dot shifted up one day, which will be future underscore days. Okay. And next I'm going to choose the columns to keep. So I'm going to set assets equal to, and actually I really don't like that name assets with an S. I kind of want to make it just asset, right? Because it's just Bitcoin. So let me just put asset here, and asset here, and asset here. So I'm just getting rid of the S, and let me rerun this cell. Okay, and then I'm going to rerun this cell. Okay, well, I haven't ran that cell yet, so that's why we got this error message. So let's go ahead and finish this and then rerun, or then run the cell. All right, so I'm just going to type asset, and I want the close price. I want to keep that column, and then I want to keep this new column that I just created called future underscore price. All right, and then I want to show the asset, or show the data. So I'm just going to type asset here, and let's run this. Okay, so now we can see our new data set, or our altered data set. So let's go ahead and create a new cell. And now what I'm going to do is I'm going to make a copy of the data set. I'm going to call this, I don't know, df, and I'm going to set this equal to asset.copy, and df is just short for data frame. Okay, so I'm going to create the independent data set. So I'm going to call this x, and I'm going to set it equal to np.array df, and I'm going to get df columns, right, which will just be the close price and the future price. Okay, and then what I'm going to do is I'm going to remove the last n days, or should I say the last n rows. In this case, n is equal to 1 from the data set, where of course n is the future days, which is equal to 1. All right, so to do this, I just set x equal to x, and put a colon here, and then put the length of the asset minus future underscore days. Okay, and this should give me all of the columns and all of the rows minus 1. So hopefully everything there looks good. Let's go ahead and let's create the dependent data set, which I'm going to call y, and that's going to contain our target. Okay, so we're also going to convert the data frame to a NumPy array. All right, so I'm going to create a variable called y, and I'm going to set it equal to np.array array, and then I'm going to give it the target column, which is the future price column, future price with a capital P. All right, I think that looks good. So next I need to get all of the Y values except for that last row of data. So here I'm going to get all of the Y values except for the last n rows, which in this case, which is the future underscore days, which is equal to 1. All right, so I'm just going to set y equal to y, and again I want all of the columns and I want all of the rows except for that last row. So I'm just going to put negative future days, and that should give me all the rows except for that last row. All right, so next I'm going to split the data into a training data set and a testing data set. Okay, so I'm going to do, let's say, 85% training data set and 15% testing data set. All right, so 85% of the data will be for training and 15% of the data will be for testing. So I'm going to create a few variables: x train, x test, y train, and y test. And I'm going to set it equal to train underscore test underscore split. And there are multiple ways you can split the data. This is just one way. So we're going to put in our independent data set x, and then our dependent data set y, and then the test size, which will be 15% or 0.15, and then we're going to give this a random state. So I'm just going to set this equal to some arbitrary value like 0, and then I'm going to set shuffle equal to false. Okay, so let's run this cell. All right, everything looks good so far. Okay, let's get the train data and transform it to a data frame. Okay, so I'm just going to type train underscore data and set it equal to pd dot data frame. I'm going to input x underscore train, and then the columns will be the same columns from our df data frame. So that's just df dot columns. Okay. And next I want to show the first 7 rows of data. So I'm just going to type train underscore data dot head and then input the value 7, and let's run this to take a look at the training data set. All right, so we can see the first 7 rows of data here, and that looks good. So let's do something similar for the test data set. So I'm going to get the test data and transform it to a data frame. So test underscore data will be equal to pd dot data frame, and I'm going to input our test data set. So that's x underscore test, and I need to give it some columns. So the columns will be the same as our data frame df. So columns will be equal to df dot columns, and then I want to show the first 7 rows of data. So I'm just going to type test underscore data dot head and then input the value 7, and let's run this cell. Okay, and now we can see the test data. Okay, so let's create a new cell, and now in this cell I'm going to initialize the setup. So this will create an information grid that contains important information about the data. And so you'll see exactly what I mean when we set this up. All right, so let's just bring this up a little bit. Okay, so I'm going to create a variable called regression underscore setup. And I'm going to set this equal to the setup function. It's going to take in some data. So in this case, our train data. It's going to take in a target. Well, that's just going to be the future underscore price column in our data set. And then I need to give it some session ID. So I'm just going to set this equal to 123. And then I'm going to use the GPU. So I'm going to set this equal to true. Okay. All right, so let's go ahead and run this. And come here, I'm just going to press enter. All right, so now we get this back. So we can see the session ID, which is 123. We can see the target, which is the future price column. We can see our original data set, which contains 2,402 rows of data and the two columns that we have in our data set. We can see that missing values is equal to false. So that means that we do not have any missing values within the data set. And then we can see the number of numeric features, which is 1, right? Because we only have 2 columns. So one column is being used for the target and one column is used for the features. Okay. So I think you all understand everything there. Let's go ahead and create a new cell. And of course, there's lots more, a lot more information in that table. But we're going to go ahead and move on for now. And here I'm going to train on all of the models. And then I'm going to sort it by the R squared. I'm going to sort it by the R squared metric, also known as, I'm going to put AKA R2. All right, and then I'm going to store the model with the best R2 score. Okay, so I'm going to create a variable called best underscore model, and I'm going to set this equal to compare underscore models. And then I'm going to sort by R2. All right, so let's go ahead and run this. And this is something that I really like about PyCaret, is that it basically allows you to compare all of these different models on your data set. All right, and for those of you who don't know what R squared is a statistical measure that represents the proportion of the variance for a dependent variable that's explained by an independent variable or variables in a regression model. And of course, right now we are creating a regression model. Okay, so let me go up here. So very nice. We can see that the linear regression model has the best R2 score. So that's what's going to be stored in the best model variable here. And that's the model that we're going to use. So let's go ahead and create a new cell. And it may not actually be the best model, but that's what we're going to be using for this small project here. All right, so now we have the model. So let's go ahead and create the model, since we have the model that we want to create. And then I want to show its prediction metrics on the training data set. All right, so I'm going to create a variable called model. This will be where we will store the model, and then I'm going to use the function create underscore model. So we want to create that best model, which was the linear regression model. And let's go ahead and run this. Okay, so now we can see the linear regression model on the test data. So you can see the R2 score here, right? This is the mean. And I think that looks pretty good. So let's create a new cell. And I guess I should also mention that these values down here should match up with these values up here. Okay, so there we go. You can see that they are the same. All right, so next let's go ahead and evaluate the model. So just type evaluate underscore model and then input the model that you want to evaluate. I misspelled that here, evaluate. All right, so let's go ahead and run this. Okay, and let's just click on residuals for an example. And so now you can see this nice metric, this nice chart on the residuals for a linear regression model, for this linear regression model. All right, so that's pretty cool, right? Okay, so let's go ahead and create a new cell. And let's get the predictions. All right, so I'm going to create a variable called unseen underscore predictions. And I'm going to set this equal to predict underscore model. I'm going to input the model. And then I'm going to give it some data that it hasn't seen before, which is the test underscore data. And then I want to show the predictions, right? So I'm just going to type here unseen underscore predictions. So let's go ahead and run this. Okay, and we can also see the model's metrics here on the test data. So we can see it has a slightly lower R2 score. And here we have the close price and the future price. And then we have what the model predicts the price to be. Okay, so for example, here we can see that this was today's, or I'm going to say that this is today. So this was today's closed price. And this right here was tomorrow's close price, which is what we're trying to predict. And the model thought that tomorrow's close price would be this. All right, so it was off by, it looks like approximately $2,000. Okay, and we can see the model was off again here, and we can see the model was off here. So you can obviously see that this model is not perfect, right? Again, this was just a fun experiment, but it did have a pretty high R2 score, and who knows, maybe if we change something up, maybe we use a different model, maybe we use different data, maybe it would be possible to make some predictions. But many people have tried, and many people have failed. So I just hope you all enjoyed this small fun little project. Well, that's the end of the video. If you want to start an investment portfolio of your own, you can click on the link below and get 2 free stocks valued up to $1,850 on Webull. We can deposit $101 or more. And don't forget to grab $10 worth of Bitcoin using BlockFi's link below. We can deposit $101 or more. Thanks for watching, and thank you to the supporters supporting this channel on patreon.com/computerscience. Again, if you would like to be a supporter on patreon.com/computerscience, then I will leave a link in the description below for that. Thanks for watching, and I hope you all have a fantastic day, and I will see you in the next video. Bye-bye.